A counter tool is provided to support convenient and rapid tallies. For example, tally occurrences of words in a list. CNT counter for word in red, blue, red, green, blue, blue. Count word plus is equal to 1. CNT. So for example, let's take an example. Collections.Counter counter object. In that, let's see the example 1. From collections import counter print CNT. It will print blue 3, red 2, and green 1. Okay. Now find the 10 most common words in Hamlet. So let's see the example. Import re dot find all w plus open hamlet.txt read lower. Let's create one file hamlet.txt. Let's put in here apple, banana, is banana, cat, apple, is the worst, apple, is that apple, cat, apple. Okay, let's go back to example. Read dot lower. Okay, counter words most. First print words okay, all words are being printed here. Now counter words most common 10. So print counter words dot most common 10. Apple 5 times, is 4 times, the 3 times, banana 2 times, cat 2 times, worst 1, that. Class collections.Counter iterable or mappings. A counter is a dict subclass for counting hashable objects. It is a collection where elements are stored as dictionary keys and their counts are stored as dictionary values. Counts are allowed to be any integer value including zero or negative counts. The counter class is similar to bags or multisets in other languages. Elements are counted from an iterable and initialized from another mapping or counter. C counter. C is equal to counter Galahad. A new counter for a iterable. C is equal to counter red for blue 2. a new counter from a mapping. C is equal to counter cats is equal to 4, dogs is equal to 8. New for the these are 4 valid. Counter objects have a dictionary interface except that they return a zero count for missing items instead of raising a key error. Z C counter X ham bacon. New Python. Example 3. From collections import counter print C of apple, it will return 0. Setting a count to 0 does not remove an element from a counter. Use del to remove it entirely. See, so says 0. Print C. Print C. So says 0. Counter objects support additional methods beyond those available for all dictionary elements. Elements return an iterator over elements, repeating each as many times as its count. Elements are returned in the order first encountered. If an element's count is less than 1, elements will ignore it. C is equal to counter A4 B minus 2 print C and C dot elements print elements counter A4 C elements A B B. Less than 1, so ignore it. Most common n return a list of n most common elements and their counts from the most common to the list. If n is omitted or none, most common returns all elements in the counter. Elements with equal counts are ordered in the order first encountered. Counter 3. D is equal to print D. Most common 4. So C is equal to 1. Most common 5. D is 1. Most common 20. Okay. Subtract. Iterable or mapping. Elements are subtracted from an iterable or from another mapping or counter, like dict.update, but subtracts counts instead of replacing them. Both inputs and outputs may be 0 or negative. So for example, Counter is this A4B D A1 2 3 subtract D print C A3 B0 C minus 3 D minus 6. Total. Compute the sum of counts. Print C dot total minus 6. The usual dictionary methods are available for counter object except for two which work differently for counters. From keys iterable. This class keys method is not implemented for counter. Update iterable or mapping. Elements are counted from an iterable or added in from another mapping or counter like dict.update but adds counts instead of replacing them. Also, the iterable is expected to be a sequence of elements, not a sequence of key value pairs. Counters support rich comparison operators for equality, subset, and superset relationships. Equal, not equal, less than equal to, greater than equal to. All of those states treat missing elements as having zero count, so that counter A is equal to 1 is equal to counter A is equal to 1, B is equal to 0. Returns true. Common patterns for working with counter objects. C.total, C.clear resets all counters. Print C.clear, print C, resets all counter. Print C. List C. List unique elements. Set C. Convert to a set. Dict C. Convert to a regular dictionary. C.items. Convert to a list of element count pairs. Convert from a list of element counter pairs. C.most common. Several mathematical operations are provided for combining counter objects to produce multi-sets. Counters that have counts greater than 0. Addition and subtraction combine counters by adding or subtracting the counts of corresponding elements. Intersection and union return the minimum and maximum of corresponding counts. Equality and inclusion compare corresponding counts. Each operation can accept inputs with signed counts, but the output will exclude results with counts of 0 or less. C is equal to counter this, D is equal to counter this, C plus D. Example 4. Arithmetics on counters from collections. Import counter. Print C plus t. For c minus d, print c minus d e2. अच्छा इग्नोर कर दिया, print c and d 1 3 intersection union. Now it will be true. It should be true. Why? Oh, now it should be true. Yep. Unary addition and subtraction are shortcuts for adding an empty counter or subtracting from an empty counter. C is equal to this, print plus C A2. Print minus C B 4. Correct? Note: counters were primarily designed to work with positive integers to represent running counts. However, care was taken to not unnecessarily preclude use cases needing other types or negative values. To help with those use cases, in this section documents the minimum range and type restriction. The counter class itself is a dictionary subclass with no restrictions on its keys and values. The values are intended to be numbers representing counts, but you could store anything in the value field. The most common method requires only that the values be orderable. For in-place operations such as C key plus equal to 1, the value type need only support addition and subtraction. So fractions, floats and decimals would work and negative values are supported. The same is also true for update and subtract, which allow negative and zero values for both inputs and outputs. The multi-set methods are designed only for use cases with positive values. The inputs may be negative or zero, but only outputs with positive values are created. There are no type restrictions, but the value type needs to support addition, subtraction, and comparison. The elements method requires integer counts. It ignores zero and negative kinds. Back class in Smalltalk Wikipedia entry for multiset C++ multisets tutorial with example. For mathematical operations on multisets and their use cases, see Nath and Donald, The Art of Computer Programming Volume 2, Section 4.6.3, Exercise 19. To enumerate all distinct multisets of a given size over a given set of elements, see iter tools dot combinations with replacement. Thank you.